In this video, we will be looking at section 4.2, which covers graphs of exponential functions. We're going to start by looking at the graphical features of exponential functions. So graphically, if we are looking at a function in the form f of x equals ab to the x, then a is the vertical intercept of the graph. So that means we are going to pass through the y-axis at 0, a. B determines the rate at which the graph grows. If a is positive, then the function will increase if b is greater than 1, and the function will decrease if b is between 0 and 1. Remember that we're only looking at positive values of b, so this is what we're looking at. The graph will have a horizontal asymptote at y equals 0. The graph will be concave up if a is greater than 0 and concave down if a is less than 0. And then the domain of these exponential functions is all real numbers, and the range will be from 0 to infinity. So we're going to graph the following functions on the same axes. First up, we have f of x equals 2 to the x, and then we'll go from there. So first up, I'm going to graph this f of x in green. When in doubt, I can always go to my y equals on my calculator and type in 2 to the x power. And then if I go second graph, that'll bring me to my table, and that will give me some points I can plot. So I have -3, 0.125, -2, 0.25, -1, 0.5, 0, 1, 1, 2, 2, 4, 3, 8. So if we play to connect the dots, and we get a function that looks kind of like this. You'll notice that we have our horizontal asymptote at y equals 0, like we saw in the graphical features. Our a value is 1 because this is 1 times 2 to the x, and we go through 0, 1 as our vertical intercept. So a lot of those things we can see in this example. G of x, I'll graph in purple. That's 2 times 2 to the x. I could just go to my y equals and type in 2 times 2 raised to the x and look at the table for that. That would be -3, 0.25, -2, 0.5, -1, 1, 0, 2, 1, 4, 2, 8. These points sound really familiar, but we can tell that it's not the same as the green graph, but it doesn't look too far off. So I wonder if we can use what we know about exponentials and exponents in general to see how these are related. Well, if we think about 2 times 2 to the x, that's the same thing as 2 to the 1 times 2 to the x. And with exponents, if they have the same base and they're multiplied together, I can add the exponents. So this is the same as 2 to the x plus 1. And if you think back to when we were talking about transformations of functions, if we replace an x with an x plus 1, that's going to shift our graph to the left by 1 unit. So the purple graph is identical to the green graph, but we have shifted it to the left 1 unit. If you prefer to think about it this way, then this is also the graph of f of x, but with a 2 multiplied out front. So that 2 multiplied out front is a vertical stretch. To get that, we multiply all of our y values by 2, and you can think of it as a vertical stretch. So this is identical to the green graph, but you can think of it either as a vertical stretch by a factor of 2 or a horizontal shift to the left of 1. Either way gets us to this new graph. Finally, we're looking at h of x equals 2 times 1/2 raised to the x. I'll graph this one in black. Let's start by looking at the table. So we have 2 times 1/2 raised to the x. So we get -316, that's going to be off my graph. -2, 8. -1, 4. 0, 2. 1, 1. 2 1/2, 3 1/4. This graph looks to me like the purple one, but reflected over the y-axis. So let's see if we can understand why that might be the case. 1/2 is the same thing as 1 over 2 to the first power. And another way I can write that is 2 to the negative 1 power. So what this function is 2 times 2 to the negative 1 to the x. And when I have a power raised to a power, that's when I multiply them. So this is 2 times 2 raised to the negative x power. You'll notice this is identical to g of x, but I've replaced the x with a negative x. That's what gives us a horizontal reflection, and that reflects it over the y-axis. Next up, we're going to look at transformations of exponentials. And this is going to generalize what we've looked at so far. Any transformed exponential can be written in the form f of x equals ab to the x plus c, where y equals c is the horizontal asymptote. So now what we have is we've introduced this plus c on the end, which usually means a vertical shift. So due to this shift, our vertical intercept is going to be shifted to 0, a plus c. When we were looking at our exponentials without the vertical shift, then our intercept was at 0, a. But now with this shift up by c, we have to move the vertical intercept up by c as well. So what we're going to do is we're going to take a look at these graphs and see if we can come up with a formula for the function that is graphed. And it says that these are going to be transformations of f of x equals 2 to the x, but we're going to show how it is 2 to the x rather than use that as information. And the way we're going to approach this is the fact that the last slide told us we can write any transformed exponential as a times b to the x plus c, where c is equal to the value of the horizontal asymptote. So let's take a look at the first one. It looks like our horizontal asymptote is at y equals 3. So we know our equation is going to be in the form y equals ab to the x plus 3, because 3 is our horizontal asymptote. Now I'm going to use some points on the graph to help me find a and b. First off, I'll start by using my y-intercept, and it looks like we go through the y-axis at 0, 2. So I'm going to plug in 0, 2 into the part of the equation I already have, and hopefully that'll help me start solving for stuff. So I'll have 2 equals ab to the 0 plus 3. So I'm plugging in 0 for x and 2 for y. But b to the 0 is just 1. So I'll have 2 equals a times 1, which is just a, plus 3. And if I subtract the 3 over, I get a equals negative 1. Now that I know what a is, I can replace it in my generic equation, and I have y equals negative 1 b to the x plus 3. I need another point to help me solve for b. So it looks like, what do we got? 2, negative 1 maybe? Let's try using that. If I use 2, negative 1, then I'll have negative 1 equals negative 1b squared plus 3. I'll subtract the 3 over, so negative 4 is equal to negative 1b squared. If I divide by negative 1, then I get that 4 is equal to b squared. If I square root both sides, I get b equals plus or minus 2, but we're only looking at positive values of b. So we get b equals 2. Now that we know b equals 2, I can go and replace that in my equation. And this is y equals negative 1 times 2 to the x power plus 3. That is an equation for this exponential. Let's see if we can try the next one. We're going to approach it the same way. We start with y equals ab to the x plus our horizontal asymptote. This time our horizontal asymptote is at -2, so I'll have a -2 out back. I need 2 points on my graph to help me solve for a and b. I'm going to start with my y-intercept, which is at 0, 1. So that'll be 1 equals ab to the 0 minus 2. B to the 0 is 1, so this is 1 equals a minus 2. And if I add the 2 over, I get a equals 3. Now that I know a equals 3, we have y equals 3b to the x minus 2, and I need another point on my graph. It looks like this goes through -1, 4, so let's use that. -4 is equal to 3b to the -1 minus 2. I can, what'd I do? That's a +4, my mistake. I can add the 2 over, so that 6 is equal to 3b to the -1. Dividing by 3, we get b to the -1 equals 6, but b to the -1 is the same thing as 1 over b. So if 1 over b equals 2, I multiply both sides by b, so 2b equals 1, and dividing by 2, I get b is equal to 1/2. So that means my equation is y equals my a value, which was 3, times my b value, which was 1/2, raised to the x, and then we had a -2 on the end. Now in this particular problem, they told us this graph was a transformation of 2 to the x, and I don't see a 2 to the x here. But I want to show you why it is still a transformation of 2 to the x. 1/2 can also be as 1 over 2 to the 1, which is also 2 to the -1 power. So if I replace my 1/2 to the x power in here, I can replace it with 2 to the -1 to the x, which is 2 to the -x. So what that means is with this equation, instead of writing it as 1/2 raised to the x power, I can write it as 2 to the -x. So this is equivalent to y equals 3 times 2 to the -x minus 2. These are both good answers. It's just a matter of which one you prefer. We're going to try 2 more just to make sure we've got this down, and this time they're not going to tell us what type of function we're transforming. So it says find an equation for each exponential function below. I'm going to follow the exact same steps that I've been doing. You have y equals ab to the x power plus my horizontal asymptote, which is 5, it looks like. I'm going to plug in my y-intercept, which is at 0, 3. So we get 3 equals ab to the 0 plus 5. If I subtract the 5 over, I get a is equal to -2. Now that I know what a is, I can plug that in. And I have y is equal to -2b to the x plus 5. And I need one more point to plug in. It looks like this goes through -1, -1. So I'll have -1 is equal to -2b to the -1 plus 5. I can subtract the 5 over, so that -6 equals -2b to the -1. Dividing by -2, I get 3 is equal to b to the -1. But that means 3 is equal to 1 over b. 3b equals 1, or b equals 1/3. So that means I can write my equation as y equals -2 times 1/3 to the x power plus 5, or like we did it in the last one, we could write it as a negative exponent instead and write it as y equals -2 times 3 to the -x plus 5. Either one, perfectly acceptable. The last one we're going to look at is this graph here. We're going to start off with y equals ab to the x power, and this time our horizontal asymptote is at -2, so we'll have a -2 out back. I'll plug in my y-intercept. That appears to be at 0, 0. So I'll have 0 equals ab to the 0 minus 2. And if I add the 2 over, I get a equals 2. If a equals 2, then my equation is y equals 2b to the x minus 2. And I need another point to plug in. It looks like this graph goes through -1, 4. So I'll have 4 equals 2b to the -1 minus 2. I can add the 2 over, so 6 equals 2b to the -1. Divide by 2, and b to the -1 is 3. Hey, that looks familiar. If b to the -1 equals 3, then b equals 1/3. So that means our equation is going to be y equals, our a value is 2, times our b value, which is 1/3, raised to the x power minus 2. Or if you prefer the negative exponent, that would be y equals 2 times 3 to the negative x minus 2. Either one, perfectly acceptable. Use which one you like better.